simplify 2 over x minus 2 plus x over x squared minus 4. If you check this question, or you take a look at this question, you realize that there are fractions in the expression. The first term is a fraction, the second term is a fraction. And inside the terms of the fraction, there are variables. So this makes the whole question algebraic fractions, which is algebraic with variables and fractions containing numerator and denominator. Now, we still check and we realize that there is no equal sign here, so we can't solve it as an equation. The addition sign in between the two fractions means that we need an LCM. But let me teach you a secret here. When you check the denominators of this particular question, there is a denominator whose exponent or whose power is more than 1, which is x squared. Now the x squared has rendered this whole expression in the complex form that we need to factorize it to make the power less than 2, which is 1, before we can continue. So we will take x squared minus 4, which is x squared minus 4. When you study this, you realize that this is coming out from the factorization and the difference of two squares, which is still x squared minus 2 squared. Since 4 is a perfect square, we can change it into x squared minus 2 squared. So it has clearly shown the two squares with a difference, which is the difference of two squares or the subtraction of two squares. In view of this, we will open and close two different brackets. Then the addition and subtraction of the two terms, which is x minus 2, x plus 2. So x squared minus 2 squared will turn into x minus 2, x plus 2 as the final factorization. So we will replace x squared minus 4 by x minus 2, x plus 2. So let's go ahead. 2 over x minus 2 plus x over x minus 2, x plus 2. So you realize that after that, you check and all the variables, powers or exponents are up to 1. There is no exponent 2, so we can proceed. Now let's continue by getting the LCM. We draw the LCM line because there is an addition sign in between the fractions. Checking from the denominator, we see x minus 2 repeated. So we write only one of them into brackets. So x minus 2. Then we will now continue to see whether there is a different denominator. Yes, of course, which is x plus 2. So x plus 2. So finally, our LCM, the least common multiple, will become x minus 2, x plus 2. Then we'll go ahead and do the division. X minus 2 will divide x minus 2 in the LCM section, and it will be remaining with x plus 2, which will move up there to multiply the numerator. So we're going to get 2 into brackets, x plus 2. The addition sign will be repeated. The same thing applies to this particular fraction's denominator. X minus 2, x plus 2 as a denominator will cancel the LCM x minus 2, x plus 2. So this will cancel this to give me 1, because the same term cancels itself as 1. 1 goes up there to multiply the numerator, and it will be 1 into bracket x. So we will continue here. Now, we will maintain the denominator, which is x minus 2, x plus 2. Then we will expand the numerator. So 2 times x will give us 2x. Then 2 times 2 will give us 4, positive 4. Then we have 1 times x will give us plus x. We will group like terms at the numerator and then simplify. So still maintaining the denominator x minus 2, x plus 2 as our LCM. We group like terms, it will become 2x, which is a like term of x, so plus x. Then 4 is a constant number, plus 4. Then we'll continue to simplify the top. Now 2x plus x will give us 3x. So we have 3x at the numerator side and plus 4. Plus 4 all divided by the LCM, which is x minus 2, x plus 2. Now, if we check from the numerator, plus 2. If you check from the numerator, you realize that 3x plus 4 cannot be simplified or cannot be added because they are not like terms. And we can also not factorize because there is no common factor. Then the denominator is in the form of a difference of two squares, so we can rewrite it as x squared minus 4. So let's make it 3x plus 4 all over x squared minus 4. That is to say, the expansion of this will give you this. So this will become our final answer for this particular expression. You can as well pause the video in any or at any particular step to verify whether you understand or not, and then you proceed with it. Thank you very much.